So this one is 3 times x inside. Since I have a product with like bases, I can split them up. Right? So the log base 3 of 3. Log base 3 of 3 plus log base 3 of x. Right? And then what's log base 3 of 3? What power does 3 need to become 3? 1. And what's log base 3 of x? I don't freaking know.
X.
It's not x.
Oh, yeah.
3 to the x is not necessarily equal to x. I just can't do it. Oh, you guys like that one. So again, log base b of xy equals log bx plus log by. Right? As long as the base is the same, and it starts off with one base, I can break it up, and then I can simplify each one if I can. I don't. All right. How else can I say this? So log base m of a c. So this is the product with like bases. So what do I do with the powers? What am I going to do with the powers? When I multiply like bases, I'm going to add them. So log base m of AC is log base m of a, that power, plus log base m of c, that power. That's it. It's always true. Period. Always. No matter what that base is. So what if the base is 3? Okay. If I have a product inside, how can I rewrite it? Log base 3 of one of them plus log base 3 of the other one. And then I can simplify whatever I can. So number 2 is going the reverse. It's got 2 separate ones. I want you to put it back together. Do this backwards. So they are the same base, right? So then I can make it 1 log. Since they're adding, what am I going to do with these guys?
3 times 4.
And log base 12 of 12 is 1. That's where it becomes useful. Right? Where you can use a property and then you can simplify the result. Number 3, the exact same thing. You got log base 4 of something plus log base 4 of something else. So it's log base 4 of the first something times the second something.
Equals 1.
Yeah, so log base 4 of 4 is 1 again. So you can see that's where this is really useful, putting things together and then simplifying. Right? It sort of feels like adding fractions and then reducing. Same kind of idea. Put it together and then simplify it. Yes, sir?
Since it's a fraction,
I mean, you could. No, again, did it matter this is a 3? Not really.
No.
If I would have put a 5, you could still done log base 12 of 5 times 4 is 20. You just couldn't have done the last step, right? So it doesn't matter what numbers these are. If I'm adding 2 logs, so I'm adding powers, I must have been multiplying. That's when I add powers, is when I was multiplying. So you could, totally could say, this is log base 4 of 1 minus log base 4 of 3 plus log base 4 of 12. Oh shit, if you wanted to. Yeah, see where that came from? I'm using the second property now. Because 1 over 3, that must have been the subtraction of 2 powers, right? I'm going to subtract the powers. Subtract the powers. That'd be. What is log base 4 of 1? What power does 4 need to become 1? 0. So then I get this here, right? I love you guys. So if I write this in a little better form, just turn it around, we're going to eventually get to the same answer, but it's taken us a long time. What do I do when I subtract powers? I must have been doing what with the things on the inside? Dividing, that's when I subtract powers. So log base 4 of 12 3, which is log base 4 of 4, which is finally 1. Oh my God.
So for addition, you just don't have to make it a, because like when
So-
we were doing our other ones, like it was, like you make it a negative every single time. So with this, you don't have to make it a negative.
So when I've got a product inside, that's the sum. I add power. So if I'm adding, it's the product. There's no negatives, right? When I'm dividing, that's the next set of properties. That's these. What would this become? I'm dividing two things, so what would the powers do? Subtract. Log base 3 of 3 minus. Why is it minus? Because what I do with powers when I'm dividing stuff, I subtract them. And sure, what's log base 3 of 3 again? 1. And I don't know what the hell log base 3 of 5 is. Oh, cool. So one thing I want you to realize, what I said earlier, would this first step have changed at all, really, on this problem? Would this first step have changed if that was a 5? No, it would have just been a 5 there. What if it would have been an 11? It would have been an 11 there. What if it would have been an 80? It would have been an 80 there, Jeff. Holy shit, man. Well, what if it would have been a 1/3? Well, it would have been a 1/3 there, Jeff. Holy shit. So I have log something plus log something. It's the product of those two things, period. Now, you could look at it like that if you really wanted to, because there is a division going on, but there's no need to. It's just making it longer than it had to be. I can just immediately combine these things.
Why was it 1 again?
Oh, what power does 3 need on it to become 3?
Oh.
That's it. Once you got them broken up, you can then evaluate each piece of it, right? And again, I know that logarithms are new. I know that. But the more I say it and the more you say it to yourself, what's the question this is asking? What power does 3 need to become 3? That's the question it's asking. It's not automatic for you yet because you haven't totally internalized the question yet. Like you have for square roots. Square roots are pretty automatic if it's a nice number, right? If I say square root of 25, you guys are like, ah, bam! You didn't have to thought, what does square root symbol mean? So it's like if I'm trying to learn Italian, I'm going to have to take a second and go, how do you say this? Oh shit, I got to, I can't just go immediately. Anybody in here know 2 languages? I'm a little jealous. And you guys are fluent in both languages? Yes? Yes. So that's really interesting. I like that. I have no idea what it's like. So do you dream in both languages, for example? Stuff like that? No? I mean, I'm serious. I'm being serious. Sometimes? And you can go between them really pretty well, right? Maybe? All right. So math is basically, for most of us, a foreign language we're not too familiar with. So you are going to have to remind yourself, what did that word mean again? Oh yeah, it meant this. Okay, that's how I do this. But square root is like a word that we all know. Sort of like we know muy bien, most Americans, right? We know certain little phrases. You can say it and you automatically know what it means, right? But if I say something else, je vais à la plage, you'd have to be like, a lot of you have to be like, what the shit is that? Let me get a... That's like one of the few phrases I remember. Besides La Corbeilla. Right? La Corbeilla. It sounds like a car. It's really a wastebasket. All right. So what about this guy? So it's going the reverse, right? I'm subtracting things with like bases. So I can rewrite it. Yes. Subtracting powers means it came from division. And sure enough, the inside you can simplify. What's 75 divided by 3? 25. And then you say to yourself, this is asking me how many 5s multiplied by 25? 2. But it's not going to be like immediate. So if you expect it to be immediate and you beat yourself up because it's not immediate, stop doing that shit. You got to stop and say, this means this, then I do this, and then the answer is that. Okay. Because this is new to you. All right. And this guy, I kind of put it, yeah.
I just made a mistake when I entered it though. I don't know why, but I entered it I got all the way down to log 5 to the 25th, whatever. But I did the answer, I put log, and then I put 5, and I put 5 as an exponent too.
Real quick, I appreciate you saying it. This is not an exponent, right? this is a base. This is a subscript. All right. You see what I mean? So that's not like a power. So a logarithm is saying, what power does this guy need to become this number? So this is not a power. I know it looks like a power, but this has been pushed down to make it like that's the base. And we weren't around when they first came up with the format of this. Right? There's a lot of ways they could have made this format better. For example, maybe not the freaking word log, for example. Right? So you guys, you don't even realize that this had to be formulated, this symbol. You're just like, well, I know what that means. But it had to be created at some point. Aliens didn't come down and say, you do this or we're going to come back and blow you up. Oh, okay, we're good. We had to create it. So they could have made this, they could have made it a box with a 5 on it, maybe, right? And that would mean the same thing. And now we would just know this symbol. We would know what it means. But they didn't. Damn it. They chose this freaky ass thing. But oh well. So what this means is, that's the base. And this is asking me, what power does he need to become this other number? And so that's going to be 2. I like it. So this needs a 2 on it to become 25. So this guy, I kind of put it here to force you guys to use this rule. So let's see, well, how do I rewrite this? Log 1 minus log 10. And what's understood to be the base there? 10.
Could you write the 10 like if you wanted to?
You could. I'm fine with it. A little bit. But it's sort of like somebody doing this, putting a 2 there. Aren't you going to be like, what? Why would you do that?
It's like you, stuff.
Do you see what I mean? I know you guys don't care as much as I do. I'm not saying you don't care. You don't care as much as I do. That's a true statement. But wouldn't that bother you a little bit somewhere? Doesn't that look weird? Doesn't that look weird?
Well, it just shows me that maybe they're new at it.
Yeah, okay, that's fine. That's why I'm saying I'll be okay with it, but at the same time, once you realize, I'd be like, okay. Because that's like, you don't need that, no. No? Okay. So yeah, if you put the little 10 there, I'm cool with it, because like Christine said, you're new with it, but at the same time, I'm not going to take points on it. I'm going to be like, oh, you don't really need that, no. So if you put a little 10 there, it hurts me to do that, but it's all right. So what's this? What's anything of 1? 0. And what's log 10? 10.
1.
0 minus 1 is negative 1. Now, if I do it directly, that's base 10. What power does 10 need to become 1/10? Negative 1 power. So I can just do it directly and get it, right? But any way you do it that's legal, they have to agree on the answer, or else one of those ways was done incorrectly. All right, now, finally, this last rule. If the inside's to a power, I could just bring that power down. So hopefully it makes sense why, but the actual working of it is easy. So that 2 can come down, and this is now 2 log 3, 8. So bam. There's really nothing you can do with that, so just stop there. So what happens here?
5 log.
Yeah, the 5 just comes down. 5 times log base 5 of x. Again, when you have something raised to a power, raised to another power, you multiply the powers. So it really still is a property. That one's just kind of harder to see immediately. So the quick way is this. If the inside got a power, you just pull it out. Bam. So what about this dude? Don't make too much out of it.
Square root of r.
Yeah, that power just comes down. Square root of r log WE. Whatever that is. I like it.
Sounds like the rest
Okay. It's going to take a little bit of getting used to, yeah.
So if you can't go any further, you just leave it.
Yeah, exactly.
Basically.
Just like anything. So sometimes this feels like, well, I didn't really do much. But if I said, reduce 24 over, what do you got, Jeff? 15. How do you reduce 24 over 15?
Oh, what?
Reduce that. No?
Oh, you can do like 8 over 1.
Yeah. Divide both by 3.
8 over
So you get 8 over 5. And you're done, right? There's still shit there. Right? There's still shit here. But you can't go any further. Who cares? You did as much as you could. I like it. So that's as much as we can do. Bam. So we stop. I like it. Okay, last thing for today. understand this before you do any of these. Don't say anything. Just think about what's got to be true here. I want 2 to the x to be 2 to the 5th. All right, now you can say something. Well, what does x have to be? X has to be 5. So really, if you can get something written like this, it's asking you, what has to go here to make it this? So obviously that has to go here, right? So these have to be equal to each other. If I get the bases equal, the powers have to then be equal. And that's where the problem comes from. X equals 5. So what's it really going to look like, Jeff? They're not all going to be like that. Oh, hell no. So the next level of this would be something like, the very, very next level would be 2 to the x equals 8. So some of you guys should be able to, but 2 to the x equals, how do I write 8 with a base 2? 2 to the what is 8? 2 to the 3rd power. So then what's x have to be? 3. So see how the whole idea is get the bases to be the same. If I can get the bases to be the same, then I can just make the exponents equal, and that's done. So they're not all going to be like this either. For the same idea holds. Let me see. Let me take a big old step up here. Let's see. 16 to the 2x minus 1 equals. What do you want, Jeff? Let's do 8 to the x. Okay, let's do this one together. So this one is a huge step up from these two. Why the hell would you do that, Jeff? Because the idea behind these two is going to tell me what to do with this. The idea behind these two is if I could just make the bases the same, I can focus all of my attention on the powers. So what base do those have in common? It ain't 8, just to save some of you. What's 8 to what power? 16. Oh. So what are they both based on?
4.
4 to what power is 8? Right? 4 squared is 16. So it's going to be somewhere. They're both based on 2. 8 is how many 2s? 3. 16 is how many 2s? 4. So I can rewrite 16. I can rewrite it as, let me put the 2x minus 1 there, right? 16 is 2 to the 4th, right? You guys with me? Equals, and 8 is 2 to the 3rd. What do you do with these? Multiply them. So you get 2 to the 8x minus 4 equals 2 to the 3x. So now what can you focus your attention on? You got the bases the same. What's got to happen now for this to be true? The powers have to be the same. So then 8x minus 4 must be 3x. I really want that. Stop there for a second.
How do you get the 2 8x? I'm sorry.
Right here.
So you did 4 times 2x.
Yes, you multiply these, right?
All right.
So x squared to the 4th power would be x to the 8th. You multiply those. You add them when you're multiplying like bases. That would be x to the 6th. When you raise something with the power to the power, you multiply the powers, right? Multiply like bases, you add. It's a long time ago. Somebody showed me that. And they had something else. That's all I remember. When you multiply like bases, you add the powers. So when you raise powers, you must multiply them. There was more to that. I can't remember. All right, let me make sure you guys are all. Rewrite both of these in terms of the same base. Why? Because hopefully, nobody stopped me here. Hopefully these two make complete sense. If the bases are the same, I can focus my attention on these. They have to be equal in order for the whole thing to be equal. So I make the bases the same if I can, And then what has to be true? I've already got the 2's there. In order for this to be equal, these have to be equal to each other. Bam. And now I've got a beautiful little simple equation. Hopefully, right? So subtract 3x, add 4, divide by 5, 4/5. I never said it was going to be pretty. Let's try another one. Do you see how the first most basic skill to do these problems is, what's the like base? 3. Because 9 is 3 to the second. 27 is 3 to the third, right? If you can't figure that out, you can't do any of these. But it can't possibly be that obscure, you know. Those are both even, so it's probably going to be base 2. These are odd. It's not immediate, but I mean, 9 and 27, 3 goes into both of those. So it's got to be base 3 that I can use. Now, if I would have put an 81 here, I could have used 3, but I could actually then have used 9, because that is 9, and 81 is 9 squared. So I got a bit of leeway sometimes.
So wait.
Yeah.
You go for the lowest common factor?
No, it doesn't.
Or does it matter?
Actually, I would rather go for the bigger one. I just have to make the bases the same. That's it. And then I can focus on the powers. Right? So you guys might realize if I could make both of these 9, then these numbers would be smaller, meaning my equation would have smaller numbers in it, which is good. I like it.
Make it, right?
You can't.
No, this one you can't. This one you got to make it 3. If that would have been an 81, then you could have had a 3 or a 9 as a base. All right, is everybody cool with this? So they both are based on 3. 9 is 3 squared. 27 is 3 cubed. And then I just put the power that's up there, out there still. They're still there. How do I simplify this?
10. What is it?
There's 2x. And then I get over here, 6x plus 3. So now that I got the bases the same, what's the only thing I have still to make true? To make these the same. So I need 10 minus 2x to be the same thing as 6x plus 3. So I can add 2x, subtract 3, I get x is 7/8. Once you get here, of course, it should be easy. So let me see. We'll do this tomorrow. Let me give you this here. This is the homework for this stuff, right? This is not in the book. It's homework from somewhere, and I've created it for you. Oh my God, that's very good. Sure. I've got a practice sheet. I think we'll do that tomorrow. And we can have a quiz next week. Yay! Yay! think it's an appropriate response.
Quiz tomorrow?
No. Next week.